Okay, this is numbers 11 through 15. Okay, problem number 11. There's negative 6 minus 3i, and you are asked to graph that. Basically, just plot it like a point where your real numbers are here, your imaginary numbers are on the vertical axis, and you're just going to go out to negative 6. Say there's 6 notches there, and then go to negative 3. Let's call this about negative 3. Plot your point, and that point right there represents negative 6, 3i. You can write it right there. This dot represents the complex number. Okay, number 12. Problem number 12, you have, let's see if I can read this. 10 minus 11i, that was one of the complex numbers. And then you're also given 10 plus 2i. And then the directions read, find the resultant sum of the complex numbers, express them in rectangular form. In other words, a plus bi, that's rectangular form. So when you add these up, you're just going to add the real portions together, which is 20, and then you're going to add the imaginary portions together. So negative 11i plus 2i would be equal to 20, and then minus 9i. And then that's your answer in rectangular form. Problem number 13. You have 6 plus 2i. They've asked you to find the modulus, and this is the same thing as finding the magnitude of a vector. You're going to use that same formula. You're going to take the front, the real component, square that. You're going to take the imaginary coefficient and square that. In this case, you get 36 plus 4, which is 40. And then you can simplify that somewhat by taking out any square root that you can actually take out there. If you break this down, break it down into 4 times 10 so that you can at least take the square root of one of these factors. That would be this. So this breaks down into square root of 4 is 2. It comes out as a 2, and the 10 stays underneath because there's no square root of 10. So there's your simplified version of square root of 40. Problem number 14. Okay, problem number 14, they give you in trigonometric form. It says write the complex number in rectangular form, and right now it's in trig form. Okay, so when they say that they want you to write it in rectangular form, that means they want you to take this complex trig number and write it like this, without any sign of r or theta. Okay, so first thing that we're going to do is we're going to get the a by multiplying this value times this. So cosine of theta is go to pi over 6, which is really 30 degrees. If you just want to think of this, you may have memorized these, and if you have, that's fine. This would be the short leg. This would be the long leg. Cross from the 30 is always the short leg. Cross from the 60 would be the long leg, and then this is the hypotenuse. So when you're doing cosine of 30-degree triangle, the cosine is represented as x over r. That's the definition of cosine at any angle. Definition of this would be y over r. And you're getting these values right off of this picture. So it's going to be 8 times cosine is x. This is the x. This is the r. This is the y. So this is going to be square root of 3 over 2. And then for your I term, you'll calculate the sine at 30 degrees, which is y over r. So that would be 1 over 2, and then don't forget to drag that 8 in. So it's 8 square roots of 3 over 2. And then also 8 times 1/2, and that would be your I term. So whether it's in trigonometric form, there's an I term, and even when it's in rectangular, there's an I term. So 8 divided by 4 right here is 4 square roots of 3. 8 divided by 2 is 4, and there you have the same number, only this is in rectangular form, whereas this was in trig form. That's number 14. Problem number 15, they give you 3 minus 3 square roots of 3i. So you're in rectangular form right now. There's no r, there's no theta, and you're going to find the complex number in trig form. So now they want you to give it in this form. Cosine of theta. So you're going to have to find a theta, because you can always put the cosine. You're going to have to find the r. And then I times sine of theta. So really what you're up against here is finding a theta and an r, which there are both formulas for. R is comes from the Pythagorean theorem, actually. It's where you take x squared plus y squared. It was called the modulus in another section. Or you can think of it as a squared plus b squared. I think of them interchangeably. Okay, this is the same thing. It was presented in a previous section as square root of x squared plus y squared, and once you get into the complex numbers, you can think of it as a squared plus b squared. So in this case, that would be 3. That's your a. And then your b is the negative 3 square roots of 3. I'll just move this over to make room. See, all of this is your b value. All of this is your a value. And you're just squaring each of these pieces. So here you get a 9, and then here you're squaring the negative 3 to give you a 9, then you're squaring the square root of 3 to just give you a 3, so 3 times 9, 27. 9 plus 27, 36. All of this is happening underneath the square root, so r is equal to 6. Okay, theta we always find with the tan function. We're going to find the reference angle first. So we're just going to go the b component, which is like y over x. It's going to go b over a. Okay, so the reference angle here would be, and then we'll worry, you don't even really need the negative right now because we can get it into the proper quadrant using the concept of the reference angle. So it's going to be 3 square roots of 3. That's like your y component. I'm just not using the negative, over 3. This cancels, and you're looking for the sort of triangle that has a tan value of square root of 3. So why don't we make that happen, realizing that the tan is y over x in a triangle. So let's see. Let's just imagine, first of all, what quadrant we're in. We're in a quadrant where a is positive, which is like the x, and the b is negative, which is like the y. So x's are positive, y's are negative. X's are positive, y's are negative. That's going to be right down here is where we're going to draw our triangle. Okay, so now we're going to figure out what this reference angle is, and then we're going to figure out what this is, which is the true theta. This is just the reference angle. Now we want the tan to be equal to square root of 3, and we know that standing right here, tan would be y over x. So it's going to be 1. So that means we are in a, let's see, long leg is always across from the 60-degree angle. This short leg, this 1, is always across from the 30-degree angle. So therefore the triangle looks like that. In the quadrant that you're in, the y's are negative. That's this piece right here. X's are positive. So you actually get the exact thing that you were looking for, which is negative square of negative 3 square roots of 3 over 3. And that'll happen in this quadrant. This is just your reference angle, so don't give that as the theta. What you want to think about is how far you would have to rotate in order to have a reference angle of 60 degrees. You're almost at 360. You stopped 60 degrees short. Therefore, the true theta is 300 degrees. And they may ask you to give that in pi form. Here, let's see what the directions say. In problem number 15, they say give the theta in an interval between 0 degrees, it says in the directions, and 360. That means they're allowing you to give the answer in degree form, so this will be fine. Okay, so that is your answer for number 15. That completes 11 through 15.